Hi everyone, Miss Colasso here. So I'm going to talk us through the 4.1.5 journal. So this journal is on theories and laws, and as we go through this, I encourage you to open up your Apex, open up a nice Word doc like this, and follow along as we discuss each question. So the first question is: a scientific law is a statement of fact that describes an action or set of actions. Laws are accepted as facts because they are always observed to be true. Examples of scientific laws are Newton's laws of motion. These laws describe the motion of moving objects. So the first part says, give an example of a scientific law you have studied or heard of. Think about what happens when an apple falls from a tree. So right there, it's asking us to think about the law of gravity, right? So that's something that is always true. We don't just randomly float up in the air some days. Like, gravity is always there, so we know that's a law. There's also gas laws. So, depending on how gas takes up space and volume, um, there, yeah, so you could put that. There's a law of thermodynamics in science that some of us talked about. There's a lot of laws that you could pick from. Just make sure you choose one that is always true. Okay. So, next question: how do you know that this is a law in scientific terms? So, a law is always going to be true, like I said. So, that's how you know that it is a law, if it always holds true. A hypothesis is an educated guess based on observation. It is an explanation of a single event based upon what is observed. A hypothesis has not been proved but can be supported by experimentation. So usually scientists come up with a hypothesis when they make an observation and they want to test something in the field. So the first part is saying, suppose that out of 10 trees planted in a yard, only 5 survived. What kind of hypothesis could you make about the observation or event? So right away, we kind of see that half of the trees are surviving. So we might want to hypothesize, why is that? Why only half? So remember, hypotheses have to be in a certain format. That is an if-then statement. I know some of you said that before you've used if, then, because, and that's great too. You always want to have the cause and effect. So you could really just be free to make whatever hypothesis you want, but think about it. So, maybe if there is not enough sunlight in the yard, like let's say sunlight only covers half the yard, then only half of the tree population will survive, or half of the trees planted will survive because trees need sunlight to grow. So something like that. Or you could say, maybe the trees were covered so they couldn't receive the rainfall, or they weren't being watered, or it was bad soil. You can make up whatever you like. Just make sure that it's in the if, then, because format. How could you test this hypothesis? Which type of experiment could you perform? So you would just describe what you would do. So let's say you were to test, how much sunlight each area of the yard gets. Maybe there's one area that doesn't get as much sunlight. You could try planting the trees not in the area of sunlight and see if that changes anything. Or plant more in the shaded area, see how that affects it. So really, whatever you wanted to try to do to test that hypothesis. How would this hypothesis be different from scientific law? Review the definitions of law and hypothesis. So a hypothesis is an educated guess. So it's something that we're just testing. We're just trying to experiment, see what could actually be the cause. A law is something that always holds true. So let's say that we had hypothesized that, trees not receiving enough sunlight were the reason that only half of them in the yard survives. But then when we planted more in the shade, they still grew. And now let's say it was because of something else. Then our hypothesis would, not be accurate. But scientific laws always hold true. So that's the difference. Okay? So number 3. In science, a theory is more like a scientific law than a hypothesis. A theory explains a set of observations or events. It must be verified multiple times by many different scientists. One scientist cannot create a theory on his or her own. Look back at your hypothesis from question 2. Could this hypothesis become a theory if you repeated your experiment 100 different times and got the same results? Can a theory be created by just one person? So no, one scientist cannot create a theory. So that's essentially it. You could go back to your hypothesis and think, even if, so you have to look closely what this is asking. If you repeated your experiment 100 different times, one person cannot create a theory. So you would need 100 scientists to repeat your experiment 100 times to see if it's replicable and reputable. Okay? So it'd be no. What two things would need to happen for your hypothesis to eventually become a theory? So looking back, you have to think about it must be developed using the scientific process. And it has to be verified by a lot of scientists. So that's when I say that it's, reputable, reliable. It's something that other scientists could do and get the same results after going through, the same methods and everything like that, receiving the same data, same results. Okay. C, what is the difference between a scientific theory and a scientific law? So now it's asking you to revisit those definitions. So we could think that a scientific law explains only one action or phenomenon, whereas a theory explains a set of observations or events. Okay? So like the law of motion, that's focused on one phenomenon, how objects move. But a theory could explain like all different types of observations or events, like the evolution theory, right? And number 4, think about the concept of evolution. Would you say this is a hypothesis or a theory? Think about the difference between a theory and a hypothesis and try to apply it to the concept of evolution. So, like we've just discussed, hypothesis is an educated guess. Theory, it kind of covers a wide variety of concepts, and also it's backed up by scientific evidence, which we know evolution is. So you can make that decision on your own and kind of rationalize it, okay? So just consider that. If the concept of evolution is defined as a scientific theory, what must be true about the concept of evolution? So it says, look over your answers in question 3 and try to apply these ideas to the theory of evolution. So we know that evolution is widely accepted as true, especially in the scientific community. It's not a guess by one or two people. There are many pieces of evidence that support evolution, such as the fossil record, similar structures between organisms, DNA, so things like that, that many, many, many scientists see over and over and over again. So that's how we know that it's more of a theory and not just a scientific guess or an educated guess. Okay? So that is this journal. I hope that helps. All right. Bye, guys.